Hello, ma'am.
Hello, sir.
Good evening. Yes, sir. Machine learning. 6 o'clock it starts. I am. Yes, sir. Everything is said. So Surya said he will join 5 minutes before. So I'm expecting him to join. And some faculty members have already joined. And I can see some students also joined the YouTube channel. Correct, sir. Uh-huh. I saw that, sir. Yes, yes, yes. Correct, sir. Correct. You will be joining, sir? No issue, sir. No issue, sir. No issue. In fact, sir, yesterday Mahinda sir also called. Actually, he asked me to call. He wanted to do some session with some foreign faculty members for 2,400 students. I said we can do. Mhm. He must have discussed with you. Right? Mhm. Correct. 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 Excellent, sir. It would be very good. Yeah. Yes, 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 yes. Definitely, sir. Definitely. Yes, sir. Yes, sir. Yes, sir. Let me know, sir. We can have a meeting, sir, and we can plan. Not an issue, sir. Just let me know. Yes. Sure, sir. And thanks for all the help, sir, with arranging this. Thank you, sir. Bye. Bye.
Gara Pandey.
Hi, Prince.
Hi, sir. Good morning. Good evening, sir.
Good evening. Good evening.
Just connecting it.
Yeah, yeah.
So, should I need to join with video or I don't know
Not
how
necessary. Not necessary. Your choice.
Okay. I didn't switch on the light also in the hall.
Welcome, all faculty members. Welcome to this session. So I'm just waiting for the guest. We'll start sharp at 6.
Good evening, sir.
Good evening, Dwarkanath sir. How are you?
I'm fine, sir. How about you, sir?
Good, sir. आप तो पहचान ही नहीं आ रहे हैं एकदम.
ऐसा कुछ नहीं, sir.
Good evening to all of you.
Yes, sir.
Good
Good
evening,
evening.
Sridharan sir.
Very good evening. Where did you manage to get your haircut, Dwarkanath ji?
Nearby only, sir. Very close to my place.
Because we are all avoiding that.
So, but anyhow, scared, but we have
I
to
know.
go.
I know.
There is no other option.
Correct.
But unfortunately, our late director has given an option for us, or what do you call, idea of using daughter or someone.
Ah.
Huh?
That as a
Yeah, our former late,
yes.
our Seshaya sir used her daughter. She.
Okay. No, I think many of us are doing that. That is a safer option.
Yeah, safer option, of course.
I know.
Good evening, Sanjay sir. Can you hear me?
Yes, I can. Good evening.
Yes. Okay. Good evening.
Sir, I have joined and others. This is not the meeting link. Another link check
The
for me.
guest is
Already
right now speaking from Singapore or
I joined
has
that.
come to India.
This link. Pallavi, you also join in that link. You check your mail. There will be a separate link.
Can you hear me, Sanjay? Yeah. Okay.
Yes, sir, but very mildly.
I don't know, some connectivity, some contact, loose contact. No. Guest is from speaking from Singapore or is he visiting India?
Oh, sir, he is in Hyderabad only.
Okay. Nice.
Hey, hello, Professor Sanjay. This is Surya.
Good evening, sir. Good evening. Welcome to this. How are you?
I'm doing well. How are you?
Good, sir. I can't see you, sir.
I have a problem with my my laptop, so video isn't working. I'm on my personal laptop,
No issues, sir. No issues.
so you have to bear with me.
No issues. No issues.
Hope
Welcome
the
to
audio is
IBS.
right.
Welcome
Thank
to
you.
IBS for this session, sir.
Thank you so much, and virtual IBS.
Virtually, yeah.
Yes.
Virtually, yeah. That's the order of the day. So I'm muting all the participants, and Surya sir, please unmute yourself, okay? So that
Yeah.
we don't have any disturbance in between. So I'm just muting all.
Yeah, I think I've unmuted myself, so yeah.
Yes, sir, I can hear you. I can hear you. So just 1 minute to go, then we'll start, sir. So we have, Surya sir, we have all the faculty members on Zoom, and we have students watching on YouTube. So the entire batch is watching, some of them asynchronously, but all of them will listen to you.
Oh, that's interesting.
And they will ask questions through the chat and all, and I'll relay the
You
questions
moderate
to
it
you.
for me. Yeah,
Pardon,
that
sir?
sounds good. You will moderate it for me, and
I will moderate, yeah.
so I need not pay an attention to the chat window, right?
No, don't do that, sir. Don't do that. Right, sir. So I think it's time. Let's start sharp at 6. Welcome, Mr. Suryanarayana, to this session at IBS virtually. And I've been following up with Surya, sir. I met him at one conference where he was a speaker, and he is a very good speaker. Let me introduce him to our audience, and then we will hand over the mic to him. So Mr. Suryanarayana, people call him Surya. He has close to 2 decades of experience in data science solutions, IT solutions, software implementation, and service delivery. In the last 7 years, he has been a passionate data science practitioner working in several domains of supply chain, manufacturing, and banking. He started his career with ADP as a solution developer and gradually grew up the ranks as or group head for the implementation. He is the alumni of Indian School of Business and is a gold medalist from their prestigious Advanced Management Program on Business Analytics in 2015. He left ADP to choose and contribute to field of data science and worked with Flex, formerly known as Flextronics, a contract manufacturing in the field of supply chain and manufacturing. A year back, he joined Development Bank of Singapore, DBS, as vice president at the DH2 Hyderabad location. He is a passionate teacher and has taught various data science programs with ISB and Times Pro. He has been an industry speaker, sharing his perspectives and thought leadership at various forums like PyConf, etc. So PyConference is where I spoke with him and I listened to him. Over to you, Surya, sir.
Thank you so much, Professor Sanjay. It's really an honor to be today here virtually with all of you to share some of my thoughts and on machine learning and the roles in data science and a bit of use cases. So I'll just I put some slides just for guiding purpose. What we'll do is I'll cover the content first, and then probably towards the end of the talk, probably I will take questions. I just need whether you're able to see my slides.
Yes, we can, sir.
Okay, so I just put it as a guest lecture. I didn't know what to put the title as. Generally, if I don't know anything what to put, I choose to keep it as guest lecture. I just put a brief agenda. Since I come from corporate, I love it to be a little agenda driven, especially. So we'll do a little bit of introduction, and then something that struck to me, and I've been a passionate follower, what's called the Data Science Foundation methodology. I also thought that since I'm talking to this young crowd, it's also important that what are the personality traits needed for business solutions using data, right? We'll do a little bit of machine learning introduction, just we'll skim through the surface of what it is, just to set the context. And then probably that will lead to the use cases, and towards the fag end, probably we'll also touch upon roles in the data domain that may be of very much interest to the audience here. Right. So this is me. This is younger me. So I think Professor Sanjay would have seen the same picture in PyConf a year back. So
and I've seen you, sir.
So I think I started. I'll just briefly probably spend about 2 to 3 minutes to give you my journey, and I'm always I always emphasize on the journey. Journey is the key thing. It's not about the outcome; it is the journey that actually makes you feel how you go. So that's what I believe personally. So I'm originally from Hyderabad, born, brought up. Even my education, both my bachelor's and as well as master's, both I went to the 2 universities. One is Osmania University College of Engineering. The other is University of Hyderabad. And then in the year 2000 is when I joined a company called Wilco International Systems. Now it's called Broadridge Financial Solutions. So I spent about 6 years working for them, and they had a prestigious client called Goldman. All of you are familiar with Goldman Sachs, an investment bank. So I spent a lot of time, working on their platform, on building a bookkeeping platform for high net worth individuals. So I spent a lot of time on how trades are made, how what happens, how settlement happens. So I spent a lot of time. Then I realized that it's been enough of brokerage services. Let me look at the other side of the fence. So ADP at that point of time had all of these divisions, which were spun off later. So I jumped the fence from brokerage services to employer services, and that's where I had the exposure of human capital management. That's where I spent a lot of time. The life cycle of an employee, which is termed as hire to retire, right? So that's the life cycle of an employee in an organization. So how do you implement the payroll systems, benefit systems, HR systems, talent acquisition systems, then retirement solutions? All that I've got a lot of exposure, and I gradually grew up. That's where I became the group head for their implementation division for large employers in North America, out of India. I had both teams in Pune and Hyderabad under my span of control. I spent last 9 years there, and then I realized that I need to do something, and that's when I was always very passionate about numbers, and analytically I used to be very sharp with numbers and making sense and building stories on it. So it came out in a couple of 360 degrees feedback saying that I'm very good analytically, and then that's when I thought maybe I should look at it from a different lens, and then that's when I enrolled into the ISB advanced management program, and that's how the rest is my journey, where I think Professor Sanjay also mentioned that then I joined Flextronics, did some work on the manufacturing side, and then did some work on supply chain. And then eventually Hyderabad calling, since I belong to Hyderabad, I had to come back to Hyderabad from Chennai. So I came back, and that's where now I'm into banking. This gives a different dimension to my career, my understanding. And I think as time goes by, my maturity of understanding data science has also increased, right? Of course, I'm also very passionate about yoga and Tai Chi. I spend a lot of time reading Eastern and Western philosophies. That's my other dimension. So, I mean, that we can park it for a later day. But with that introduction about myself, I thought what would be relevant today before I get into the thick of things. I wanted to probably give you a flavor about this whole approach. I hope you're able to see my pointer.
Yes, sir.
So if this was published in March 2016 by IBM, and I think the day they published it is probably the next day is when I downloaded it and I went through it. It must be available. If you type Data Science Foundation Methodology white paper, IBM March 2016, you will get a detailed. Each step in this is actually described very, very elaborately, or very, very briefly, but it conveys a lot of meaning. So everything starts with a business understanding. Now, I cannot emphasize enough on this point. And I think if there is one key takeaway that I want all of you to take away today is this. If there is no business understanding, all the steps are irrelevant to me. This is the most important step for me, because I'll tell you, we are not building algorithms for charity. At the end of the day, they have to make money for us. There needs to be some monetization, some business value for it, right? If that isn't there, then I don't see why we better not do it. Because I come from a very business focus, because I wouldn't do anything unless I see value, right? Even collecting data, I need to see value. Is there value in it? And sometimes it's a chicken and egg problem. One may argue saying that, how would I know if there is a value generated or not unless I do it, right? Yeah, agreed. But I think the thing is, first you have to ascertain what is the problem that you are trying to solve, what is the business understanding, then emphasize whether there is an analytical approach, then start look at what data requirements you need, right? In some cases, you may have this piece already, you would have started collecting a lot of data in your data warehouses, right? And in some cases, you may want to collect more data elements, right? But everything has to start from here, right? You cannot go back and revisit what is the biggest. And I don't think there is any business today that does not have problems, or does not have it's like a smooth affair. No, I don't think so. Every business at whatever level you are, you will have problems, and there are enough problems for data people or data scientists to solve, right? If the business people tell you there aren't enough, I think they are lying. I think there will be enough of problems. Either they want to cross sell or upsell or find new products that you may want to market. There could be so many avenues that you may want to explore. Right? Now, data understanding is also one area, because you would spend majority of the time on this area, because if you look at a bank or any other, you will have so many data sources. You will have your sales data at one place, you will have your inventory data at one place. You have to make sense out of it. Some are captured real time, some are captured on batch mode, some are captured on, there is a lot of thing goes on. So the data understanding, what I call the data discovery aspect, it's very important. And then eventually you have to merge all, what is your single source of truth, right? Whether it is a good record or a bad record, if you want to call it, you may want to construct it and keep it. So this is the majority of the time that you spend as a data professional, right? Where you keep going, you enhance your understanding, and then eventually once you have come to a level of maturity, that's when you start going to the modeling. And at times from modeling you come back again to actually transform some of the data for your preparation phase and go back, and you see a lot of these iterative steps that are there. And then from modeling, you evaluate, you will build 3 or 4 models, blah, 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 and you will say which one is best. And then you deploy, and then you also want the feedback, I predicted something or I told something. Is that the truth? Is that what the reality is? Because you have predicted ahead of time. And reality may be different. Now you want wherever the reality is different from whatever you predicted. So you feed back it to the model and you fine tune your model. And then you keep on repeating. Right. So this has been my what they call guiding principle in this field. I would urge that if some of you want to take up this journey as a in the data profession, probably this is probably you have to take a printout and stick it on your desk. Keep reminding that whenever you are taking up, at which phase you are, what are you trying to do, and then going back to the business understanding. Right. So. Now, I thought key traits, I want to talk briefly about it because I know you all are looking at, taking up roles in data. It's very important. What are the key traits that I would look for if I was hiring someone or if I would like to partner with someone to do something? The first key trait, I see these two are, you have a boy data scientist and a girl data scientist. And first thing that is important is the learning, right? How quickly, imagine you will not know everything on day one. You have to be very sharp, agile in your learning, right? That's a key trait that I look for. The second thing is curiosity, right? They say curiosity kills the cat, but not in this case, right? So curiosity is very much curiosity, but it has to be balanced with the right means of addressing your curiosity, because curiosity is your hypothesis, if I may call it. And then you need to know how you have to position your hypothesis, right? And then how do you test it, right? Have evidence of it, right? Don't be in a hurry, right? Curiosity with hurry will be disastrous, but curiosity with a good thought is very essential for the data people. This is the most important thing. This is where I see. I'll tell you the way I look at it is, we as data scientists or we as the data people, we run a lot of experiments. Believe me, 9 out of 10 experiments are a failure. But the one that is successful is the one that pays for the remaining 9 and much more. Now, if you do not have the patience and you don't know when the successful experiment is going to come, right? And I think that patience and perseverance is very, very essential. Don't have patience even if you see failure. In fact, I have seen when I did my first modeling experiment, I spent 6 months seeing failures. I was very depressed. But at the end of the day, I found it's like that apple falling and then something striking and then you go implement it, right? Theory, and this is also very essential. I am a very practical, I'm an applied, what they call applied scientist, right? I don't really care about theory much. I am more applied. Can I apply it? If you ask me anything that you teach me, I look it from a practical standpoint, and it's very essential that. But when when I apply it practically, I also read about its theory. So I am also balanced. Do I know the theory behind it? Why is it like this? Is it a special case? So I keep inquiring all about that. So find the right balance between your theory and practice. Right, both are essential. But I would peg a little bit on the practice side. This is very, very important, especially people who are dealing with data. You have to keep calm and double check, because based on your insights, someone is going to take a decision. It may not be life and death, but it involves money, right? So keep calm, double check that your analysis is right, cross verify with business, keep on retesting your numbers, right? This is very essential. Essentially, this goes back to the identify what is the here the you is the data people and they is the business people. Identify what is the common area between what you want and they want. Traditionally, all data scientists or all data people want to apply the so-called sophisticated algorithms and models. Everything. Let's go apply. But that may not solve the problem sometimes, right? So identify what is that you're trying to solve. That comes from the business understanding in the data science foundation. Understand what is their biggest problem. You may solve their problem with a simple sorting of data. You need not have any sophisticated, and then thereby enhancing the decision making process, right? So start somewhere small and then start building it, right? And that's when you get their buy-in to move forward, right? That's the key essential. Keep it very simple. At the end of the day, business people like it to be simple, right? They like it to be simple. You complicate stuff that they do not understand, it becomes you won't get their buy-in. The adoption becomes a problem, and then there will be no repeat business from them too, right? If they think that you're complicating stuff. So start very simple and then start building, so that you gradually earn their trust and move forward. This is the last one, and I kept this purposefully towards the end. It's very important that you do a reflection of yourself at the end of every engagement. What's your story? What is the key learning from this whole thing? What went well? What didn't go well? I think these are all probably the main traits that I look for in data people from a personality standpoint, apart from they having their knowledge on the algorithms and also crunching the numbers, and then also weaving a story. All that is additional, but these are all the personality traits that I look for, right? Professor, you need to keep a check on my time, because I'm not keeping a watch on the time.
No issues, sir. No issues. I'm keeping.
Okay. So, well, I tell you, I just thought I'll put this thing for the benefit of everyone to have a common understanding of what is that I think what machine learning is, right? So it all started off, you can go look it up, artificial intelligence. They say that, see, the whole concept started about mimicking a human brain, right? What is that so unique about human learning? It's not that you want machines to learn, right? So there are two aspects that comes out of this. The first one is called generalization. Now, generalization is if I look at a small baby, right? Maybe a boy of 2 years or 3 years old, you show him red color apple and say this is apple. You show him at different positions the apple and say this is apple, apple, apple. And then tomorrow you show him a green color apple. The boy or the girl actually generalizes it and say that this is an apple. He may say it's a ball also. That's a different scenario, but I'm just saying the ability to generalize from past experience is a unique thing about human learning, human thinking. We generalize things, right? So the way you put it in machine learning is the ability to predict or assign a label to a new observation based on the model built from past experience. Right? That's the concept of generalization. That's number one, very, very important concept that I would like you to take away from today. Second one is semantics. Now, quite often, people give this example, the ability to assign meanings to all parts simultaneously based on the context, so the whole makes sense. And it's very important, right? If I say, I prefer orange to apple, you all know that I'm talking about the fruit orange to apple. But if I say orange has filed a suit against apple, definitely fruits can't file suits against each other. So it must be all corporates, right? So you know that I'm talking about corporates. So the semantics is the ability to assign the meaning based on context. Generalization is based on your ability to assign a label based on past experience. Semantic is ability to assign a meaning from context. These two are something that you want to teach machine. That's where you have these algorithms, which actually help you to do. And most of your semantics come from your NLP or computer vision kind of area, right? But this is not what interests us. Definitely, this is what we want to use and drive decisions from data. What is that I want to do? I'm not doing machine learning for charity. I want to drive decisions from data. Decisions from data that generate business value. In fact, I will add more sentence. Generate business value. I can generate so many decisions, but I want only those decisions that generate value. Very, very important aspect, right? Because if you can provide so many insights from data, you can't act on all of them. But there will be top 3 or top 4 that can generate the maximum impact from you from a business standpoint. Identifying those are also important, right? So this is where our interest lies. This is where our interest lies, driving decisions from data. I put this slide, I borrowed it from some website, the IDAP blog on machine learning. I thought it's important that I call out, what machine learning. I'm sure you guys would have seen, and maybe it's part of your curriculum, but I just thought I will revisit it once. The first one is unsupervised learning. Unsupervised learning is where you do not have a label, right? You're trying to form associations, or you're clustering, you're grouping data, right? And unsupervised learning, they say, is the best form of learning. That's what kids actually, especially from the ages of 0 to 5, they spend a lot of time on unsupervised learning. They keep looking around, trying to see what can be grouped together, what cannot be grouped together. There is a heavy amount of unsupervised learning that happens in their minds, right? Supervised learning is again assigning labels to all of your data points. You're saying that all these data points have a label A, all the other data have label B, and then you're trying to do. Typically, there are 2 categories. One is classification, where you're looking at categorical variables. Regression is continuous, and then there are a lot of examples that go. These are all examples that like fraud detection, right? Image classification, right? And customer retention, and of course diagnostics, whether from a health standpoint. Regression has a lot of predicting inventory, weather forecasting, right? And of course forecasting the demand, estimating life expectancy. All these are continuous variables, and those fall under regression. But there is a combination of these two that is called semi-supervised. But there's no category that I've put here. But there is one more category where you can combine these two to do, where you do a unsupervised, create labels, and then apply a supervised technique on it. Some use cases do have that kind of scenario. There is a third, the fourth category, which is called reinforcement learning, right? Especially your autonomous car driving, all that, right? And your robot navigation. So you have a clear-cut algorithm which says there is an action, there is a result, and there is a payoff, right? And then based on that, it actually learns what to do, right? So kids also exhibit this reinforcement learning a lot, right? So depending on the scenario, especially people in the age group of 3 to 5, depending on the situation, they know which one gives the maximum payoff and they actually act according to. The same thing can be applied for autonomous. I have 3 or 4 decisions to take, which is the best one I choose, and I keep on learning and I keep on improving myself, the algorithm or the agent on it, right? So these are the 4 or 5 4 main categories in machine learning. Right? Now I just thought I'll touch upon this because it's very essential that how do you actually do test generalization, right? So typically, let's assume that you are doing a supervised learning, right? For the sake of this particular plot, I thought it is more relevant because I can keep on building modal complexity, right? I can keep on. As I increase the modal complexity, it is like I'm memorizing it. It's you're making it, every data point, the model memorizes. It's like when you were kids, you know, you used to memorize the tables, right? 2 1 2 2s are 4, 2 3s are 6, right? How do you do that? Actually, what we do is we actually split the data into 2 components, right? Based on a random seed, we actually do a random sampling and we split it into training set and validation set. And then we put the validation set in the back pocket. We never show it to the model. And then we keep training the model. And then we keep on upping its complexity. At some point, you will see that the accuracy of the validation set drops. The red line is dropping. You have a hill, right? Whereas, because you're showing the same training data, it keeps on memorizing it, right? And memorizing is also called overfitting in my language, right? So this is all your overfitting area. So you want to look at that sweet spot, and this is where till here it is generalizing because this data point, the red data point, the model has never seen. It has always in the training it has seen the blue data point, but it has never seen the red data point. Till here it generalizes well, and from there it drops, and you pick the complexity of the model as this. So it may change, like, you know, if you have a regression problem, the polynomial of x's could be the complexity. If you're talking about decision trees, the depth of the decision trees could be, right? So for each method, you know how to up the complexity, and you keep on upping until you find the sweet spot where the validation accuracy starts to drop. And then you say that this is the best learning algorithm that I have, right? So I thought I'll also give you that perspective, and I thought then probably we can talk about a few of the use cases. I just put it since I'm a banking, I'm highly regulated, and I'm also governed by the copyright and other issues, so I can't share what banking use cases that we are working on. But I could go back to my experience where I worked on the manufacturing side and probably, you know, give you some sense of what is needed, right? So before I start going deep into each of these use cases, the context is very important. You know, what is the business setup, right? If I say workforce design, what is workforce design? Under what context am I talking about workforce design? If I say inventory prediction, under what context am I talking about inventory prediction? Those are all very essential. So I will spend some time. I think this slide probably I'll spend the majority of the time, maybe the next 10 to 15 minutes would be on this slide, and then we can go to the next slide on the roles, right? So workforce design is, most of you know Flex is a contract manufacturer, right? What does Flex do? Flex is they actually do manufacturing for original equipment makers, typically mobile manufacturing. So they manufacture from a small chip to a very big server, right? Now they operate in about 200 countries, and then they have so many sites all over the world. Now it is essential that since it's a manufacturing company, you have 2 categories of labor. One is called direct labor. Direct labor is the labor that is involved in the actual manufacturing process. Indirect labor are the ones that are like data scientists, HR, right? Marketing, administration, general plant administration. All those guys you apportion to cost to each of the manufacturing lines, right? Now, say I am establishing a new plant in somewhere in say Malaysia or say Indonesia, right? I want to open a new plant. Now, what is the ideal indirect labor force that I would need to start? Right? How do I do my workforce planning? Right? You have a lot of data all throughout your 200 plants where you are running 24/7 operations, where you've been, you know how many people you need from an ideal standpoint. Now you want to start a new one. Can't you build a predictive model that sends you for a greenfield site? What would be the ideal approach that you would need? That was the whole objective of this. Why do we need it? One is probably that helps us to plan and establish something. Second is, it also tells me that on an average, I require so much of workforce to run. Can I benchmark it and see if I can do better? Or do I know which sites are doing better, which sites are doing worse? Can I actually stack rank them and see why for the same kind of work, some sites are having lesser workforce, some sites are having higher workforce? Is there a parity comparison? Maybe the ones that are having lesser workforce have done automation. They have some best practices the other work sites can take, right? Those are all some things that you can do in your workforce planning, especially for indirect labor, right? So that was the whole intent, and there are a lot of data points like what is the value added margin, what is the complexity of the product that you are making. All those factors are taken into account to build the workforce design. So there are more than a dozen or 15 variables that go into actually deciding the workforce, what is the revenue, vagera, all of that you put, and then you create a regression equation, and then you use it to benchmark, and you use it for greenfield operations, etc., etc. Right? That's the context for workforce design. Inventory prediction, you all are MBA students, so you know it better than anyone else. It's very important. Inventory is a cost, right? So, is there a way that I can end up predicting what is the inventory? One, is it just enough if I predict what the inventory is? No. I also need to have some intervention to reduce the inventory. Is the inventory in the finished goods? Is the inventory in raw material? Is it the inventory in work in progress? Where is it? Then what is the intervention? So if I am able to ahead predict that for each of these, that we're going to end up with this much inventory, I can plan better interventions. If there is a lot of inventory in finished goods, then probably you need to work with your end customer to see why the hell the inventory is sitting in my warehouse. Why are we not moving it? Is a problem? Is a contractual obligation? What is it? Probably these are all inputs that you may want to take back to frame a contract at a later stage. So there are a lot of byproducts that come out of such kind of analysis, right? If the inventory is in raw material, are we buffering? What is happening, right? Or is it because it's an electronics industry, mobiles and by the time a mobile comes, a new mobile, it's a very small life cycle that you have for a model, especially in mobiles, right? So why are we stocking so much inventory? Is there any way we could reuse this inventory elsewhere? Can we be more smarter, right? Right, those are all the questions. While we come up with a dollar value, but we also have to go and see where the inventory, which kind of commodity is having. Is it electronic commodity or mechanical? What type of contracts we have with vendors? Can we push it to, well, the raw material sits with us, can we push it, throw it into their books of record? So you can do all that gimmicks or whatever you want, right? But that will be a guiding principle saying that, this is what you're going to end up this quarter. This is what you're going to end up this year. So you have some lead time to actually intervene and take corrective action. Now, my argument has been that while you intervene, it is also important that you measure the effectiveness of your interventions. I've intervened at a particular place. I would also need to measure how effective was the intervention. And quite often, in data science, these are very, very important, where your interventions are You don't measure, you tend to forget, I've done it. No, you have to measure it so that you come back and then see that, yeah, if I didn't intervene, I would have ended up here. I intervened, I saved. That is what is the business value that I was talking earlier, right? So you have to think of those kind of interventions where you can categorically or clearly capture those kind of value, right? That's about inventory prediction, right? Supplier behavior, this is very interesting. I'll tell you, the context is very, very important, right? The context is that for a Flextronics that is a contract manufacturer, you will have so many suppliers. Let's assume you have 10K suppliers. And then there are about 1 million active components that you are sourcing. Because you make small chips to big servers, right? So there are diverse product portfolio that they have. They keep sourcing so much. Now, the situation in the market is also not so great, right? The customer says that, look, you make 10 units of a particular electronic component, right? That was the initial contract. Suddenly, the customer realizes that there is no enough demand in the market. There's a demand fluctuation because he or she will have their own way to assess market. They will assess. And then they'll say that we don't need 10, we only need 5 now. What typically happens is as soon as I get 10 demand, what I do is I actually go and then place orders with my suppliers to say what are the raw material that is needed. Some may be raw material, some may be, some I make, some I buy, because like chargers I buy, I make the phone, I integrate the charger and I sell it. So suddenly that guy comes back and tells me that, no, I don't need 10 now, I only need 5. Now I have to go back to each of these suppliers, and there could be many suppliers, right? I have to go back and say, I am cutting down my order. What happens? Is some suppliers agree, some suppliers don't agree, right? Because they may say that you have placed, of course, there are terms, there are contractual obligations, all you get. But there may be some suppliers who have been consistently very positive towards you, right? Right? Who have been always honoring your commitment. Whenever you said, I don't need 10, make it 5, they make it. Some suppliers, whatever you do, they say nothing doing. But do you know what is your supplier behavior? Some suppliers, if the demand quantity is small, they may oblige. Some may not. There are a lot of possibilities that arise, right? Some may go by value, right? There are several things that can you prioritize this to your procurement team, thereby saving. Because maybe you're chasing the wrong guy. That guy wouldn't listen. Maybe you need to look someone who's in the gray area, right? Maybe that supplier may listen to you and honor your commitment or dishonor. The other flip side is suddenly the guy says there is a lot of demand for my electronic component. I have made my demand from 10 to 20. Right now the problem is I need more. Hey, give me more material. I need more material. So your other challenge is you are either on this side of the spectrum or that side of the spectrum. And you can't be on a wild goose chase with all these suppliers, right? If you are able to prioritize based on past data of how the supplier behavior has been, wherever they have, honored your commitment or honored your request or did not honor, can you stack rank and give it to your procurement team, thereby, channelizing their efforts more meaningful? That's probably very essential because at the end of the day, what are you trying to do? You're trying to help your business teams or ops teams to take good decisions, spend their time more effectively. That's where that's the value that you would be generating, right? The other thing that I see from this kind of analysis is also you would know who are the suppliers who have been over a period of time consistently honoring your requests, right? You may want to strategize them. At the end of the day, entire manufacturing is a big supply chain. You have to keep your suppliers happy, hale and healthy, support them, right? Right. Like Toyota does. So you need to have that thing. So you identifying who are with you in the need of the hour is also very important, so that you incentivize their behavior, to say that honor them. You can do all of that, right? So that could also be. And then you can also make them the preferred supplier, give them a status, something like that. The last one in the predictive section is on the real-time defect prediction. This has been a very interesting area. I couldn't do much in my tenure at Flex, but I think something that actually I love, because this is the area where we spend a lot of time talking to the ground staff. So typically, mass manufacturing of electronics happens through a technology, especially on the printed circuit board. It's called surface mount technology. It's called SMT, right? When you pass the board through several machines, and then there are readings captured for these, and then you put it through an oven where you solder it, right? And then eventually, then you test it. Then suddenly you realize that this board is bad. There's nothing you can do. After you solder the electronic equipment, there's nothing you can do about it. It's trash, right? No, but if there is a way in between where I can tell you the likelihood of whether this board is going to be defective or not, right? Before it gets to the oven where it gets soldered, right? If I am able to do it, I can pull out and thereby saving. But the trade-off is, if I start pulling more boards, I'm going to impact the efficiency of the line. Please understand, I have to churn out some 700 boards per day. If I start pulling out everything and causing disruption to the manufacturing line, what will happen? You will not hit your productivity targets. So there is a trade-off that you may want to match, right? Now the other issue here is, I may give, after machine 1, what is the likelihood of a defect? After machine 2, what is the likelihood of a defect? After machine 3, what is the likelihood of it? Because it passes to 3 or 4 machines before it gets to the oven, right? And then thereby I can educate the line personnel there to see what has to be pulled, what has not to be pulled. You have to tune it, and this is something that you have to do with a lot of precision, working with the ground staff, right? We couldn't do much on that working with them, but I think we built a real-time defect prediction. The entire process, one PCB going from start to finish, is about 5 minutes, depending on the complexity of the product that you're manufacturing. But imagine if you are able to stop at 2 minutes, and within 10 seconds, you're able to say whether this is going to be a defect or not. That's something that we were able to replicate and show, which was good, and thereby giving a chance where it will show on the screen of the line personnel, and then they can take a decision. At the end of the day, he or she may choose to stick to the decision or move it, saying that no, the probability is too less. I'm willing to go with it. It's a trade-off between the false positive and false negative that you would like to, depending on the costs that play out. Okay, so those are all on the predictive side. Prescriptive side, I think we've done something on the context, on the semantics side. The last one, I would only talk about 1 or 2 here in the interest of time. I think we're already at 6:45. Yeah. Smart assigner is like, we get a lot of these, since again, going back to the context, we have so many suppliers, so many accounts payable, right? We receive a lot of emails, a lot of traffic. We need agents that need to act on each other. We have to keep our suppliers happy. At the end of the day, they supply our raw material, right? So they keep sending that something has not been paid, something or duplicates, a lot of issues that come to this team. Now, it's important that if you're able to read the context, all of them send emails to their a centralized email box. Now, if there is a smart assigner, and then some of your suppliers may be preferred where you want to give them special attention. Some of your manufacturing sites may be wanting to have special privilege because you're probably producing or manufacturing a cutting edge product, right? You want dedicated service. So there are a lot of rules of how these tickets get assigned to agents who may want to act, right? What used to happen is there used to be a small team that used to go through each of these emails and assign cases. Now, can we look at the email and probably assign, probably ascertain what are the entities in the email? Based on the entities, can I smartly assign it to the agent? Like if I'm looking at Hyderabad site, I'm an agent. all Hyderabad site issues will be routed to me. Any email comes, I know, I read the email, I know the contact, the site is Hyderabad, so automatically it gets sent. Very simple. That's something that will save a lot of money and time. It's a low-end work, and then people can focus on what to fix and all, instead of looking at reading. The Smart Assigner we've implemented. It's an integration of 3 cloud platforms. ServiceNow, you guys are familiar. Then we also have Microsoft Outlook, which is also O365. That's also on cloud. The third one is it was built on Azure. All these 3 combined using cutting-edge NLP algorithms working together, and it is seamless. It runs in mini batches, collects, and then assigns. And as you all know, no algorithm is perfect. There will be some amount of cases that you may not want to assign. For those, you may want to have 1 or 2 agents who would review it and assign it. But you don't need an army of people to do it, right? Others are all self-explanatory. I probably would skip this and then move on to what is more meaningful for today's lecture. I purposefully put it towards the end of my talk, right? There are a lot of roles in data. I'm not going to talk about the traditional roles that data has, but I thought I'll give you a perspective of what are the roles that are available in today. And believe me, the market is still evolving. It will take its own time to evolve, but some of the corporates have evolved and are using these roles. Some aren't. Some, they're combining and calling all of it together as a data scientist. They are at the several phases of their maturity. But it is very important that don't imagine the data scientist knows everything. Right? I think when I started, I played the role of a data translator, data analyst, data engineer, machine learning engineer, and then putting everything into, and then also running the ops, data ops also I did, which I didn't put it here, but yeah. But what is relevant is that this is where I think you're all MBA grads, and I think this is where the translator is the most important role for data, right? I think where I see an opportunity is your understanding of the business understanding and using data science. Bridging the gap between data science and domain expertise. And that's a key skill that is very, very essential. Because believe me, algorithm and all is almost taken care. It can be automated fully. But your domain expertise, domain understanding is probably the most essential thing. And that's what if there is one key takeaway from today's lecture, what did Surya say? Business understanding, quote, unquote. That's what you should take away from today's lecture or today's talk. Data analyst this is like data analyst is like, we don't have so many roles in India, unfortunately. Some corporates do have, some don't. But for me, all these 3 are combined as data scientists. To some extent, even the data translator, right? Collecting data, wrangling, and providing tangible insights through graphics or visualization or storyboarding. That's what the data analyst is supposed to do. Quickly collect, wrangle, mix, integrate all that he has to do and provide tangible insights from the data. He's like a junior data scientist a little bit, because he will not apply complex algorithms, but he or she can apply simple. Data engineering has become very essential, because data engineering is a key skill today, right? Because I have so many sources of data. Can I get all of this data at the doorstep of the data scientist or the data analyst to analyze? I don't want data scientist, the precious commodity. Let him only focus on how to beat the data to get relevant insights from it, right? So you want to take away all of his or her focus from engineering to science, where they're only trying to experiment and then make more sense out of the data, right? So that's the focus. Now, data scientist he's always thinking about complex algorithm. How do I frame based on the business problem? He or she frames the hypothesis, postulates the hypothesis, tests it, and then says that provides insights, and again goes back to the business team. There's a lot of iteration that happens, and eventually you agree, right? This is all very crude way the data scientist does, quick and dirty way. Now, at the end of the day, is that the end of the story? No, that's not the end of the story. Now I want this thing to be actually productionized or operationalized. Why? Because I want it to be automated so that I get insights automatically. That's where the machine learning engineer comes. He looks at, he optimizes the code, he applies software engineering practices. He also, some of the models may require recalibration if there is a data drift. He analyzes all of that, builds automated pipelines so that it becomes seamless for the business guys as well as the entire team to monitor and then move forward. So the machine learning engineer is, once we freeze on the experimentation and all, he or she focuses on entirely, automating A to Z, from pulling the data from the source till providing insights onto the desktop of the business guy. It should be so seamless, no manual intervention, right? And then he will optimize, because data scientists will use code, and some of the algorithms will take. I have an algorithm; it will give you very good insights. It will give you 100% pakka insights, but it will give you after 1 year. Do you want it? No, I want it to be quick, faster. That's a key skill that the machine learning engineer would do. He will write more efficient code, which is faster. Data scientists would have done some big thing, it would have taken 2 days. The challenge of machine learning engineer is probably write some fundo programming to make it faster, use some better speeder algorithm, speeder infrastructure to make it run, right? So that's what is the machine learning engineer. Now it all depends on your appetite of what you are good at, right? You have to choose where is your sweet spot here. But I think more or less this is where your core data would fall under. I'm not going to talk about, traditionally there are data stewards, database administrators. Those would still remain. I don't think there may be, but there is something that is coming up which is probably for industries that are regulated, especially for banks and financial as well as pharmaceuticals, where you need these governance. Am I using my data really responsibly, right? How do you know your model is not biased? These are all some of the things that are going to get to prominence as we embark on this journey of data science. Regulators are going to ask, how do you test your model is not biased? How do you know there is a data drift? How do you know when are you going to train the model? You can't say a static. Someone said, no, all models are right. That's wrong. All models are wrong, right? It depends on the context. They're right to a certain period. They're right to a certain scenario, but after that they are wrong, right? When does it necessitate for the data team or the data science team to retrain or recalibrate models? These are all the questions on the table, and I think in the coming years you would see a lot of focus on these areas. All right. So that's a little bit about the data, and I just want to take a few minutes. I think we have some time, so I'll just take a few minutes, about 2 to 3, before I open it up for questions. I think, as I said, you need to evaluate your business value ahead. So I would say business value and the effort involved. If the effort is humongous and the business value is minimum, there is no making sense. You're all MBA grad, so you would look for where the effort is minimum and the return is the maximum. That's where you would try to focus your energies. Right? It's important that what I have learned in my life is engage with ground zero employees. The guy who is going to use your insight. Don't talk to his boss's boss's boss. That guy will not know anything. Please believe me. I'm not against anyone, the senior management, don't get me wrong, but talk to the people who will use. They will have better suggestions for you when you're building or doing something. Right? Talk to them. Find out how would they use. Is it better if they give this insight 10 minutes ago or 20 minutes? It's all, the timing is also important, right? What would help them? What would make their life easier? If you talk to them, the adoption also will be easy. Instead of you coming up with some solution and going ahead, that may not sell, but talk to them. And validate your data upfront. Do not believe anyone. They will say that I have a lot of data and all you go, have you seen? Is it snapshotted, or is it real time, or the same record gets updated, whereas the previous history is where? Validate all that. Do not believe anyone unless you see it with your own eyes, right? and then keep on validating. Sometimes you see with your own eyes, make sure your colleague or your buddy also checks and sees the same thing as you see it. That's also essential. And focus on data collection. Some of these problems, I don't have data, but people are in the lazy mode. I don't have data, yeah, what will I do now? No. If you don't have data, have a plan to start collecting data from today. If not today, tomorrow you can build a model and help in aid in decision making. That's also very, 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 very essential. And most of these people have this thing that we have done one data science project, over. No, that's not over. It's a journey. It's not a destination. You've started a journey. You have to fine tune, as I spoke earlier on the governance piece, right? When do I recalibrate my models? What do I do? It's a journey, right? So you are starting a journey. You are not taking the train, getting down and say, I've done one data science project. I am the king of the world. No, that's not the key message here. The key message is you've started on a journey. This is the little step, and you need to keep on improvising and improving your models and making it more robust and more effective. That should be the goal, right? So that's all I had, Professor, and thank you. I am ahead of time as usual.
Thank you, Mr. Surya. Thank you, Surya, sir. It was an excellent presentation. There are some questions. First question that is from me. May I share this deck with the students? Is it okay if I do?
Yeah, you can share.
I can share, right?
Please.
Thank you. Now, Professor Ravendra is asking, what does the text in black represent in the slide on use cases?
Oh, no, I'll tell you. These are prescriptive. These are more cognitive kind of stuff.
Okay.
Cognitive or context, semantic based.
Okay,
right?
okay.
Prescriptive, okay. Yeah. I'll tell you. I'm a lazy person, so I've used some of the slides that I've used for some other talk, and I've pasted. There, the focus was on classification and regression, so I called it out.
Okay. You haven't called it out, so that was the confusion.
Correct.
Okay, so one more question that keeps coming back is, what is the difference between analytics, machine learning, artificial intelligence, data science, business intelligence? So how do you differentiate?
Okay, I'll tell you, this is a very, not a controversial, but it's a very, all interesting. See, you start off with business intelligence is more about diagnostic, it's retrospective in nature.
Okay.
Right, where you are trying to assess what happened historically, right?
Correct.
And then provide some dashboard information to your business guys, right?
Okay.
But as you go, now the natural progression for business intelligence is about what will happen next. Right now, I know that this is what the way it is. So where will I end on my inventory? I know historically I've been doing like this. Yeah, agreed. But can you tell me where I will end? Now, these are all methods or techniques that you use to get to predictive. You may want to use a statistical learning method based on a regression, or you want to use a machine learning, which in some cases is a black box for you. So you don't know what is driving your. See, there is also explainability piece, right? So you want to explain something, right? But that is where machine learning comes. Artificial intelligence is where you do not know. If you take a typical example of neural network is, for every of the machine learning, you have to create a feature vector to say that these are all my inputs to the model, right?
Correct.
Now, in a artificial intelligence, I don't know what are my features. So I feed it into a neural net where it actually derives the hidden layers in the neural net, actually gets your features. At the end of the day, if you ask me from a business point of view, I really don't care. What is my business objective? If my business objective is explainability, I go with statistical method. If I'm not bothered about explainability, then I'll go with my machine learning or the black box. But nowadays, the cutting edge, even the black box, to some extent, you can also tell what is the explainability, which variable is causing the prediction, right? Or which variable is causing for your value to go up or come down, right? So there are methods and all, but I think while people may get confused, but I think the end goal is, are you helping solve the business objective? I think keep that in mind, right? So
Correct. So, I mean, a lot of these terms are used interchangeably. That's why I think people get confused.
correct. But more than the verbatim, I think I'll tell you one experience that I had, Professor. I think when I went into one discussion,
Mhm.
one of the business heads actually asked me this question: Are you going to use deep learning?
Mm, mm,
I fell off my chair actually. I didn't even know what the business problem was.
Solution was upfront.
Exactly.
Solution looking for a problem.
Correct. So there is a proverb that I always keep referring. Depending on the snake, you choose the stick.
Correct. Correct.
I don't fix the stick first, right?
Correct.
So I think while it is important to know the distinction between these, but the most important thing is where you apply. Come from an applied, perspective, right? So yeah.
So another question Professor Surjit is asking, does classification mean confusion matrix?
Yes. Oh, it's so confusing, right? I think, Professor Surajit, I think confusion matrix is classification, but there you're talking about binary classification, wherein you have either. So one of the key elements of a confusion matrix is you have a trade-off between false positives and false negatives. So you choose based on what is your cost of false positive versus cost of false negatives in any given scenario. Where do you spend more, right? Do you waste more time on false positive, or you're okay with false negatives? Where is your tolerance that is having lesser tolerance? Based on that, you tend to optimize and then build your models. Uh, that's what we have done in the real-time defect, where the material costs were high, so you would like to have lesser false negatives. So you keep on actually using that confusion matrix as a tool to derive business value at times.
Right, sir. So Professor Ravindra has another question. What is the technology stack that one uses to implement data-driven solutions in the production stage?
Okay. Uh, so tech stack, I'll tell you. Basically, you need a robust data pipeline. So you end up either using all of these open big data stack, either streaming data, your Kafka or something, and then you have a big data lake where you ingest the data. And then you use, because you want to productionize, you use either Airflow or OpenShift to schedule all of these jobs. For computation distributed processing, you end up using Spark cluster. That's what most of the corporates use. So you build around this stack. And then, of course, programming, you have Python is the anchor, because Python connects to a lot of these big data stacks very easily. So Python is your anchor that helps you to connect out to all of these, right? And then there are some cloud-based analytical solutions like AWS or GCP, Google Cloud Platform, or Azure. You may end up using any one of them, where they have even more robust things, if based on your solution and based on your data sensitivity, other things that you want to address when you want to move to cloud and all. But predominantly, if you are building in-house, distributed data processing using Spark, Python being the anchor, and for scheduling all of it, you either for ingestion and all, you use streaming, either Kafka or Scoop, based on what is the source of the data, and then from a pipelining and scheduling your jobs, you use Airflow or OpenShift to actually have, and then containerization if you want scalability based on what's your use case. If more people are using, that becomes the DevOps of the story. That becomes like any other IT project.
Correct. Right, sir. Okay. One more question. How do you sample from a data for creating training set and validation set when the data is time series in nature?
Oh, you do sequentially, What you do is forecasting problems always start with the first question to ask is, what is your forecast horizon?
Okay.
What is your appetite to ask for how many data points that you would like to forecast.
Okay.
Not, so you start there, and then what you do is, if say I want to forecast for the next 3 data points,
Okay.
then I should have a minimum validation set of t minus 3. So I take t minus 3 till t as my validation set, and from 0 to t minus 4 as my training set. I build a model there and then evaluate on these 3 data points that I went back. Then what I do back testing. I keep on moving one data point, and then I see how robust my modeling methodology is. Right?
Correct.
So it is sequential in nature. Unlike when you do cross-sectional data, you actually do a random sampling. Here you do sequential, meaning t minus 3. You take sequential data points. The reason why you do that is you may want to end up measuring autocorrelation, all of those elements to see how the fit is, right? To test your fit. Yeah.
Okay. So one more question based on your presentation, sir. So how do you decide, or when do you say that this model is getting complex? When do you make?
Yeah, this is the graph.
Correct. So how do you come to this point?
You keep on testing, no? So you start with, you keep on upping the complexity. Either you start here with low complexity. As you go here, you keep on increasing the complexity. You can write a script which keeps on increasing your complexity. And then suddenly you will see at a tipping point where the validation set accuracy drops off. You will know it. Then you snap it off and say that this is my sweet spot. I think there are a lot of search algorithms in Python which will, you put a grid search, it will tell you which one where to
Where to
do it.
stop? Okay, we'll get
Yeah,
that. Okay, right, sir. So
all this is solved for you. Most of this is solved. What is not solved is understanding the business, generating the value, and then the other piece is after I have the insight whether the guy is acting on it or not.
Correct.
See, typical example is I give you a phone, Google Map, you will say from Gachibowli to BHEL is this route, but it's a straight road in this case. But I'm just telling you. But Google Map gives you another route. You will say I know better, and you override it.
Correct.
The importance is the behavioral change. So what is left out in the whole roles is there is also a human behavior that needs to be behavioral specialist whom you want to. Is my insight being used? Is there a feedback? That is also not quite often. So you need a very cross-functional team. People tend to forget. You need a very big cross-functional team to execute such big data projects.
That on the technical, from the technical point of view, if a student wants to get into a machine learning role, technically what he or she should be comfortable with?
So they say that imagine there are 3 circles, right? The first circle is domain. Domain is important.
Okay.
The second circle is your key algorithms and machine learning. You know length and depth of what the algorithms mean, where to apply, the applied knowledge of algorithm. The third circle is your computer science, your software engineering.
Okay.
You need to be expert in 2, right? Two out of these 3. Right. And then essentially it is also important is if you want to become a machine learning, you definitely need to be very good at your programming, either Python or R, because at the end of the day, you will not do it on paper. You will have to write code to crunch some of the complex pieces.
Correct. Correct. Professor Ravindra has another question. Is R programming and the ecosystem of R packages widely used in industrial applications?
Oh, yeah. I am an R programmer, professor. So I would answer yes, even if it is no.
That's a biased opinion. All opinions are biased by definition.
Yeah, but I really, my view, professor, is that it doesn't matter. What I do, I'll tell you. Guys, this is very, very essential and very important. I do not want to reinvent the wheel.
I do not want to
reinvent the wheel.
Reinvent the wheel. Okay.
If I know that there is a package in R, I will end up using R. If I know there is a better package in Python, there are some packages that are available in R that are not available in Python. Like for palette optimization, although I didn't talk about, there is a very good package in R. I'll end up. I am like applied guy. Even Excel gives me a better solution, quicker solution. I will use Excel. Excel has a very fun to data analysis suite. I will use that. In fact, my first product that I actually gave was on an Excel only.
Okay. Okay.
So these are all tools. That's the point that I'm trying to drive. These are all tools. You see what is a business value, what is the easy way, where will your adopters adopt it, in which fashion, identify that sweet spot and attack. Right? So, yeah. I don't know whether I answered, but R is used widely. No doubt, even today also I use it very extensively.
I know where are you on the R versus Python debate, but what I have heard or read is Python is used more because there are more programmers in the ecosystem, right? And Python is the programmer's language, so to say. Statisticians use R. Is that kind of correct?
Yeah, actually, it's not. Python has a better, I told you right earlier also, it's an anchor that connects to your big data ecosystem very fast.
Correct.
It has good connectors. R doesn't. R and is also because it has an academic bent, where you want to run a very small experiment and all. It's quick and very easy to run an experiment in R. And scalability is one issue with R that is not with Python. So that's where Python wins a little bit.
Correct.
But even today, I end up using R so extensively. If I have to build a small POC, I build it in R, and then we look at scaling it to Python if needed.
So at your level also, you use R. You are a hands-on.
Oh yeah, I am a very hands-on guy.
Yeah.
Give take, I compete with my data scientists. It's a challenge.
And beat them hands down.
No, but I think it is very essential because that keeps you very, very agile and nimble.
Current competitive also, right? So any specific case where you have used Bayesian analysis, Bayesian statistics?
I've not touched Bayesian yet, but I think, but I'm doing some research on Bayesian right now, and I see a lot of use cases that can use Bayesian, right? So Bayesian is typically you have a prior distribution of data.
Correct.
You have a new data point. You combine prior distribution with a new data point that gives you a posterior, and then you measure the probability of occurrence and you take a decision based on it.
Correct.
I haven't used it very extensively, but believe me, over the last 2 months, I've been studying Bayesian very closely.
Okay.
And my intuition tells me is I'm going to apply it somewhere soon.
Okay.
Maybe in assessing. Basically, it is a good to take the prior beliefs and then use it with current data points to make a more sound judgment. Those kind of use cases, especially where I haven't explored, but I think that's one area that I want. And I think there is a very fantastic course on Coursera that I'm doing right now, which is called Bayesian Statistics by Concept to Data Analysis and Techniques and Models. There are it's a 3-course program.
It's a specialization.
It's a specialization, and it's offered by University of California at Santa Cruz. It's a wonderful program. You should, Professor, and I would strongly encourage if someone is Bayesian. I haven't seen such a good program. In fact, I finished the first module a few days back, last week itself, and you won't believe the quizzes I had to redo 2-3 times to get the concept. They're so challenging and so thought-provoking.
That's good, sir. Yeah.
Good that I don't know who asked this question, but it was an interesting question.
Which one, sir? This question?
Yeah, the Bayesian one.
Bayesian. I am not getting the name. It's called Taplock Admin.
Taplock Admin. Okay, thank you, Taplock Admin. That's a good question.
Oh, it's Kaushik Bhattacharya. Okay, he's a finance professor.
Oh, wow. Finance uses many use cases, although I don't recollect any top of the mind. But portfolio allocation uses some of the Bayesian, I believe, if I'm not wrong. You may end up.
And he is an expert on Jacobian and Hessian, and he is.
Oh yeah, good. So I know from where it is coming. Yeah.
ISI. Right, sir. So that will be all for today, sir. Thank you very much, Surya, sir, for agreeing to this invitation and enlightening us with your perspective. It was a great learning for all of us. I think it was the same for the students, and look forward to meeting you. Maybe in the next presentation, we'll talk about Bayesian, sir.
Hopefully I come up with a new some use case and I can share my perspective. Definitely.
Right, sir. Thank you, Surya sir. Thanks for
Thank
your
you, thank you, thank you to
For the-
IBS, and also Professor, you too, for patiently making sure that I deliver this. Thank you for all the help and cooperation. Really appreciate it, and all the very best.
Thank you very much, sir. Bye.
Thank
Good
you.
night.
Bye. Good night.
Thank you, everyone. Bye bye.
Bye, sir. Thank you.
Bye.
Bye.
Sir.
Thank